Hello, I have a quick quiz question for you. Can you spot the atmospheric aerosol? Well, I'm not talking about this. This is just a kind of deodorant. No, I'm talking about the haze you can see over there across the skyline. Atmospheric physicists call this aerosol. Well, what is aerosol and why is it important? This short video introduction will explore these two questions.
Aerosols are small particles or droplets of solution suspended in the atmosphere. They're often called particulate matter. There are many different types of aerosol in the atmosphere, coming from many different sources. So let's have a quick look at what some of those major sources are around the world. This map shows aerosol optical depth, a measure of the total amount of aerosol in the atmosphere. It's been averaged across several years. The areas in blue show places where you don't generally get much aerosol. The areas in red show places where there's often a lot of aerosol. There are many different sources of aerosol contributing towards the distribution seen here. Some of those sources are natural. For example, when strong winds blow over the desert, they can lift up dust into the atmosphere. This dust aerosol is then often blown over the Atlantic Ocean, with some of it sometimes even reaching the Caribbean and other parts of America. Another natural source comes from the ocean. When strong winds blow over the ocean, they can lift up small droplets, and then these droplets can then often evaporate, leaving sea salt in the atmosphere, something called sea salt aerosol. Another source is man-made in origin, the typical air pollution with which many of us are familiar. For example, when coal is burnt, it can release lots of sulfur dioxide, which can then be turned into sulfate aerosol in the atmosphere. It's these sorts of man-made aerosol pollution which are responsible for the Haze events over places like Beijing, as is often reported in the news. Another source of aerosol is that of biomass burning. When forests are burnt, or when peatland is burnt, it can release a lot of smoke, a lot of soot into the atmosphere. It's actually this biomass burning which is responsible for most haze events over Southeast Asia, for example the one I showed in the video at the beginning. Why is it important that we understand about aerosol? Well, let's have a look at a few of the effects of aerosol. When there's a lot of air pollution, like in the image shown here, we can breathe lots of small particulates in, which can be very bad for human health. Aerosol can also have an important impact on the climate. In this schematic on the left, there isn't any aerosol. The sunlight is free to reach the Earth's surface, warming the surface. However, on the right, there's an aerosol layer. This reflects a lot of the incoming sunlight. Therefore, less sunlight reaches the surface, and this leads to a net cooling compared to the situation where there's no aerosol. This cooling of the surface can sometimes be referred to as global dimming, and can have a very large impact, particularly on regional climate. Aerosols also play a very important role in the formation of clouds. They act as a tiny nuclei on which water vapour condenses to form cloud droplets. Clouds play a very important role in the climate system because they reflect a lot of the incoming sunlight. Changing the amount of aerosol may change how much sunlight is reflected. They may also affect precipitation, which has implications both for flooding and also drought. These effects actually represent some of the largest uncertainties in projections of future climate. We need to understand these effects better in order to improve our understanding of the climate both now and in the future. A lot more work still needs to be done. This is the end of this short video introduction to aerosols. There's a lot more information online, but if you have any questions, please don't hesitate to get in touch. Thank you for listening. Bye bye.